Welcome back everyone to the Hello World guide. This is another episode of the Advanced C++ Asteroids game series, and in this video we are going to implement the actual movement and logic for our asteroid. So currently if I were to go ahead and open up my game here and run it actually, so what you should see is that we do have an asteroid in our scene just like we had in the previous video. Well, because we implemented that in the previous video, kind of the asteroid drawing, but currently it's standing there and does nothing. And let's make it a bit more active and do some things. For that, I'm first of all let's create a float called Asteroid Spin, which will let's set to 50 for example for now. Even though I think 50 might be a bit too much. And in the asteroids update method we are going to update in the update method we are going to add to the angle the asteroid spin multiplied by the delta time, and I'm going to reduce this down to 30, or actually let's reduce it to 25. Let's run that, and what you should see is that we get a spinning asteroid on our screen. Yeah, it's spinning currently. Of course it's not moving, but it does spin, and that is kind of the effect that it had in the original game. And now we need to implement its movement. For that we will have to go under our asteroid, and each asteroid will have a different direction. So we'll create a vector 2 called direction in the private and constructor as well, and we'll initialize it in here just like we did for the bullet. It's pretty similar. So we'll basically allow the asteroid to be initialized with a specific direction. Now in the update function, let's just say position plus equal asteroid speed multiplied by direction multiplied by delta time. And the speed of asteroid, let's just define it here as say 70 for example. Well, yeah, let's just keep it at 70. And when we are creating a new asteroid, we are for now just going to make it move on the x-axis. Also let's increase that to 100. 70 is perhaps a bit too low. Let's see. Perhaps we'll like to keep it at 80. So let's run this, and of course you can try to play around with these values and tweak them to whatever you like. It doesn't matter. And you can see that our asteroid is moving and it's also spinning, but when it goes off the screen it completely goes off the screen. What I would like is that when it goes off, starts to go off the screen, it should basically bounce back towards us. So we need to implement some kind of functionality for that, and that functionality we need to implement for both our player and our asteroid, that they should not be allowed to go out of the screen. So we need to implement some way to do that. Now as for making the asteroid bounce off the walls, we are going to implement that in the future video, and in this video we are going to limit the player movement right now. So for that we will set the position.x of the player to, we'll just clamp it between for the minimum we'll take like C++ standard library does not have a default clamp function. For that we can just take the minimum and the maximum, use them in succession. For the maximum we'll take it between position.x and 0, since we don't want it to decrease beyond 0, and for the maximum we can just pass the screen width. And our screen width is not defined yet. We need to go up here and define our screen width to be 1200 and screen height to be 900. And also I'm going to have to define the player sizes, and you will understand the reason for that in a second. And these sizes you can just kind of look at your player coordinates to kind of guess what the bounding box, the AABB axis aligned bounding box of the player should have the size. And if I go in here, the problem with this approach is that currently our position.x is situated at the center, and it would allow our player to kind of disappear halfway out of the screen. We do not want that, so we are going to add to this our player width by 2, and from the screen width we are going to subtract our player width by 2. And for the y we are going to do a similar thing, but use player height and screen height and also position.y. We need to subtract this, by the way, not add this. Now if I run this, I have actually made a fundamental mistake in here, which will cause the player to immediately go back to the center of the screen. By the way, this needs to be done outside of the if statement, not inside. And in here, while we may have that, actually you can do it inside of the if statement. That is going to work quite well as well. The reason for that is because we are not really modifying the player's position apart from when we are doing it inside here. Anyway, if I were to start to move my player, it will slowly go back to the center. The reason is that we are actually subtracting this from our position.x, and then we are setting our position.x to be that. We do not this is not actually correct. So instead of this 0, we'll not place the 0 here. Instead we are going to take this player width divided by 2, and we are going to cut that, and we are going to paste that whole value here. What that is going to do is it's going to give us the essentially same results as far as the clamping is concerned, but the only thing that will change is that it will allow us to now be able to not allow our player's position to be actually affected by this operation if it's in the center, or in the boundaries of the screen already. So let's run that, and this is pretty simple and understandable, I guess. And let's run this, and what you can see is that I've got my player. I can go up and I can kind of move around freely, but as soon as I try to go out, you can see the wall blocks me and I cannot go out anymore. And similarly for the x-axis and for the other sides, hopefully it will work as well. So yeah, you can see I cannot go out of the screen anymore, and that works quite well. And let's test the other side of the x-axis as well, and you can see that everything does work. So yeah guys, that's pretty much it for this video, and I'll see you in the next one, in which we'll implement the more functionality for actual asteroid, which still goes out of the screen, and we'll then later also implement a asteroid spawning system, so that we can have like asteroid spawning continuously throughout the game. And after that we can finally get to making our bullets collide with the asteroids. So this stuff we'll do in the future videos. Make sure to stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.